Hello class, welcome to Connected. Humans perform numerous tasks from the time they wake up till they go to bed. They use numerous tools to accomplish these tasks. Simple examples include a toothbrush, a toothpaste to brush teeth. These objects that we use are sometimes at rest and sometimes in motion. Examples of objects in motion could be the flying birds, the swimming fish, the moving cars, and the walking pedestrians. The planetary bodies such as the planets, stars and galaxies are also termed to be in motion. In certain conditions, we conclude that a certain object is in motion concerning an indirect incident. For example, we understand the direction and the motion of the air by observing the surroundings. We either observe the direction of the sand, leaves, and the branches of the tree, or hold a paper, check the hanging clothes, etc. We all know that the earth rotates and revolves around the sun. We have also studied this rotation causes the day and the night and also causes the seasons. But have you ever wondered why are we not able to sense the movement of the earth? The motion of an object may be perceived differently by different viewers. An object can be in motion from the perspective of one viewer but can be addressed from the perspective of the other viewer. Let us understand this concept by going back to a very commonly used example. Imagine yourself standing on a road. While you stand there and the bus arrives, you perceive the bus and the seated passengers to be in motion. Meanwhile, the passenger that you perceive to be in motion when he looks at his co-passengers, they all seem to be stationary. Understanding motion is a complex concept. It is sometimes described that certain objects are moving in a straight line while certain other objects are moving in a circular path. Some may form a rotational motion while others can form vibrational motions. In some conditions, an object can form both rotational and vibrational motion. This chapter is going to help us understand how to describe the motion of an object along a straight line. We will also understand how this motion can be explained in the form of a graph or a simple equation. We shall also learn some parts of how to describe circular motion. In activity 8.1, the question asked is to define whether the walls in the classroom are at rest or in motion. This question can be answered by saying that the walls of the classroom are at rest concerning the students sitting inside the classroom. But for someone who is passing through the corridors looking inside the classroom, the wall of the classroom seems to move. In activity 8.2, the question asked is that if the reader has experienced that the train in which they are sitting appears to move while the observer is at rest. This question can be answered by saying that in a condition where the observer is sitting in the train, he perceives the person standing outside the train is in motion. Motion is also described based on controlled and uncontrolled motion. In the case of uncontrolled motion, like the event of a flood, the uncontrolled motion of the water seems to be dangerous. But in the case of the generation of hydroelectric power, where a controlled movement of water is used to generate electricity, this motion is considered to be a useful motion. Motion can be described by the timing of the location of the object concerning a specific point known as a reference point. Let us consider the example of a school. The location of a school is described as 2 kilometers north of the railway station. In this case, the position of the school is determined concerning the position of the railway station. Hence, the railway station is considered as a reference point. The reference point is chosen according to our convenience, hence it is mandatory to describe the position of an object concerning a specific point. Unless determining the reference point, it is impossible to define the position of an object. The most simplified form of motion is the motion of an object along a straight line. Suppose an object commences its journey from point O. Point O is considered as a reference point. We will consider points A, B, and C as the representative of positions of the object at different instances. The motion follows the path from C to B to A. On its way back, the object follows the same path. Displacement is a concept that helps us understand the overall motion of an object. With the concept of displacement, we can determine the final position of an object concerning the initial position at a given time. In this activity 8.3, you are expected to take a meter scale and a long rope with these measuring instruments. You are expected to walk from one corner of the basketball court to its opposite corner along the sides. Calculate the distance that you covered and the magnitude of the displacement. Distance is defined as the actual length covered by a body while it moves between fixed positions. Displacement is defined as the actual path covered by an object between two fixed points in a straight line. The device which helps us understand the distance the vehicle has covered is known as the odometer. Let us consider the example of a car that is driven from Bhubaneswar to New Delhi. It is observed that the difference between the final reading and the initial reading on the odometer is 1805 kilometers. The total path length travelled by the object is OA plus AC, which is 60 kilometers plus 35 kilometers equal to 95 kilometers. 95 kilometers is the distance travelled by the vehicle. Hence, we can conclude that distance can be expressed in terms of the number without disclosing anything about the direction. Specific quantities can be determined just by expressing the number. In the same example, determine the distance between the final position C of the object and initial position O. On calculation, the obtained numerical value will give the displacement of the object from O to C through A. For the motion of the object from O to A, the distance covered is 60 kilometers and the magnitude of displacement is also 60 kilometers. During its motion from O to A and back to B, the distance covered is 60 kilometers plus 25 kilometers equal to 85 kilometers, while the magnitude of displacement is 35 kilometers. It is observed that the magnitude of displacement 35 kilometers is not equal to the path length of 85 kilometers. It is also observed that the magnitude of displacement for the motion of an object can never be zero. Distance can never be zero, but displacement for the motion of an object can be zero. If the object begins its journey from one position and ends the journey at the same position, the initial and the final positions coincide, hence the displacement results to be zero. Hence, we can conclude that distance and displacement are two physical quantities useful for determining the motion of an object. These quantities can also be used to locate the final position of an object concerning an initial position at a particular time. A few questions related to the topic studied above are mentioned in this slide. Let's begin answering the questions one by one. Answer 1. An object that has travelled to a certain distance can have zero displacement. If the object begins its journey from a certain point and ends the journey at that point itself, the initial position and the final position of the object coincide, resulting in the displacement being zero. Answer 2. Side of the square field is 10 meter, hence perimeter will be 40 meter. Time is taken to cover distance 40 seconds, therefore 1 meter in 1 second. Distance covered by the farmer in time 2 minutes 20 seconds is 140 seconds. Total number of rotations is total distance by perimeter equal to 3.5. Therefore, the farmer will rotate 3 full rounds in 1/2 round of the field. At this point, the farmer is at point B from the origin O. The displacement according to Pythagoras theorem is 10 square plus 10 square equal to 200 root. Square root of 200 would be 14.14 meters per second. Answer 3. The statement A stands true for displacement since if an object starts the journey from a particular point and ends its journey at the same point, the initial and the final position coincide and hence the displacement is zero. Moving on to the next concept of the topic known as uniform motion and non-uniform motion. Suppose an object is moving along a straight line. It travels 5 meters in the first second, 5 meters in the next second, 5 meters in the third second and 5 meters in the fourth second. This object is covering 5 meters per second, which means it is covering equal distances in equal time. Hence, this motion in which an object covers an equal amount of distance in equal intervals of time is considered as uniform motion. Objects that cover the unequal distance in equal intervals of time can be considered as non-uniform motion. Examples of non-uniform motion could include a car moving on a crowded street, a person walking in a park. Object A in table 8.1 is following uniform motion as it is moving a distance of 10 meters every 15 minutes. On the other hand, object B is moving unequal distances every 15 minutes, hence it is following non-uniform motion. If the bowling speed in figure A is 143 km per hour, it means that the ball travels a distance of 143 km per 60 seconds. This bowling speed does not remain constant throughout the game, hence it is an example of non-uniform motion. The signboard in figure B tells the speed about that is permitted on the particular road. If the driver follows the speed of 50 km per hour, then it can be considered as an example of uniform speed. The time taken to cover a distance by different objects is usually different. Some objects may take a long time while some objects may take a shorter time. The rate at which an object moves also differs from other objects. To determine the rate of an object, one of the ways to measure is the distance travelled by the object in a unit of time. By definition, this can be called the speed of an object. The SI unit of speed is meter per second. This is represented by the symbol ms raised to minus 1 or meter per second. The other units of speed include centimeter per second and kilometer per hour. One needs to specify the magnitude of the object while determining the speed. The speed of an object does not necessarily have to be constant. Most of the objects will follow a non-uniform motion. Hence, the rate of motion of such objects can be explained in terms of their average speed. The average speed of an object can be considered as the total distance covered divided by the total time taken. Average speed is total distance travelled by total time taken. If an object travels a distance s in time t, then its speed v equal to s by t. Consider a car travelling a distance of 100 km in 2 hours. Its average speed is 50 km per hour. The car might not travel at a constant speed of 50 km per hour. It might sometimes travel faster or sometimes slower. Consider an object travelling 16 meters in 4 seconds and then 16 meters in 2 seconds. We are expected to calculate the average speed of this object. The average speed is calculated by the rule distance covered upon the total time taken. The total distance covered in this case is 16 meters plus 16 meters equal to 32 meters. The total time taken in this case is 4 seconds plus 2 seconds equal to 6 seconds. Therefore, the average speed of this object is equal to 32 meters by 6 seconds equal to 5.33 meter per second. The rate of motion of an object can be compared if its direction and speed both are stated, and the quantity that specifies both speed and direction is known as velocity. Velocity is the speed of an object moving in a definite direction. It can be uniform or variable. We can change it by changing the speed, direction of motion, or both of the object. For example, a car is moving along a straight line with a variable speed. The magnitude of its rate of motion can be expressed in terms of average velocity. It is calculated as we calculate the average speed, that is, total distance travelled by total time taken. In case of an object changing its velocity at a uniform rate, the average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, initial velocity plus final velocity by 2. Mathematically, it is represented as VAV equal to U plus V by 2, where VAV is average velocity. U is initial velocity and V is final velocity. The unit of speed and velocity is same, that is meter per second. Activity 8.6 expects you to take a walk between 2 points considering the average walking speed is 4 km per hour. Calculate the distance. Activity 8.7 gives the situation of the thundering in the sky. You are supposed to answer why light travels faster than sound, that is, why we see the lightning first and then see the thundering. Answer 1. Speed is the time rate at which an object is moving along a path, while velocity is the rate and direction of an object's movement. Answer 2. When the body is moving in a straight line, the average velocity is equal to average speed. Average velocity would be equal to average speed when the total distance travelled equals the net displacement of a particle. This happens when a particle moves along a straight line in a fixed direction. Answer 3. The odometer measures the speed of the vehicle. Answer 4. In uniform motion, the object moves along a straight line, that is, the path of the object is a straight line. Answer 5. Time taken is 5 minutes equal to 300 seconds. Speed of signal u is 3 into 10 to the power 8 meter per second. Since speed is distance by time, distance would be speed into time value equal to 9 into 10 to the power 10 meters. Let us understand the question given below. The question is, the odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and meter per second. Solution. Distance covered by car S equal to 2400 minus 2000 km equal to 400 km. Time elapsed T is 8 hours. Average speed of the car is VAV equal to S by T equal to 400 km by 8 hours equal to 50 km per hour. Let us understand the question given below. The question is, Usha swims in a 90-meter long pool. She covers 180 meters in 1 minute by swimming from one end to the other and back along the same path. Find the average speed and average velocity of Usha. Solution. Total distance covered by Usha in 1 minute is 180 meters. Displacement of Usha in 1 minute is 0 meters. Average speed is total distance covered by total time taken equal to 180 meter by 1 minute equal to 180 meter by 60 seconds equal to 3 meter per second. Average velocity is displacement by total time taken equal to 0 by 60 equal to 0 meter per second. Therefore, the average speed of Usha is 3 meter per second and an average velocity is 0 meter per second. If an object moving in a straight line follows a uniform motion, the velocity remains constant with time. Hence, the change in velocity is 0 at any time interval. In case of non-uniform motion, the velocity varies with time. The velocity is different at different intervals of time at different points. Hence, the change in velocity is not 0 at any time interval. To measure the change in velocity of any object, it is essential to introduce a physical quantity called acceleration, which is a measure of the change in velocity with respect to time. Consider A equal to the acceleration of the object. The initial velocity is u and the final velocity is v in time t. Acceleration is v minus u by t. If an object follows this kind of a motion, it is considered to be accelerated motion. The acceleration is taken to be positive if it is in the direction of the velocity. The acceleration is taken to be negative if it is in the opposite direction of the velocity. Suppose an object is moving in a straight line, its velocity increases and decreases within certain equal intervals of time. In activity 8.8, you are given 4 instances whose examples are supposed to be given by you. The examples are A. Dropping off an object, B. Applying brakes to a running car, C. A moving train, D. Vehicles in traffic. Let's understand and solve the example given in the lesson. Initial velocity u is 0 meter per second in case 1. Final velocity v is 6 meter per second. Time travel t is 30 seconds. In case 2, initial velocity u is 6 meter per second. Final velocity v is 4 meter per second and time travel t is 5 seconds. To find acceleration in both cases. Acceleration A is v minus u by t. Case 1, a equal to 6 minus 1 by 30 equal to 0.2 meter per second. Case 2, a equal to 4 minus 6 by 5 equal to minus 0.4 meter per second. The acceleration of the bicycle in the first case is 0.2 meter per second square, and in the second case it is minus 0.4 meter per second square. Let's discuss the answers to the questions given in the slide below. Answer 1. The body is in uniform acceleration when there is an equal increase or decrease in velocity of the object within equal intervals of time. The body is said to be in non-uniform acceleration when there is an unequal increase or decrease in velocity of the object within equal intervals of time. Answer 2. Initial velocity u is 80 km per hour. Final velocity v is 60 km per hour. Time t is 5 seconds. Acceleration is v minus u by t equal to 60 minus 80 by 5 equal to minus 4 meter per second square. Answer 3. U is 0 km per hour. V is 40 km per hour. T is 5 seconds. Acceleration A equal to v minus u by t equal to 0 minus 40 by 600 seconds equal to minus 0.06 meter per second square. Graphs are effective in giving basic information about a variety of events happening together. Consider the example of a live telecast of a one-day cricket match. One bar on the graph shows the run rate of a team in each over. As we have come across earlier, a straight line in a graph helps in solving a linear equation having two variables. Line graph is generally used to describe the motion of an object. The line graph shows the dependency of one physical quantity. In this case, quantities such as distance or velocity depend on time. Let us learn about distance-time graph. The distance-time graphs are used to represent the change in the position of an object with respect to time. The scale of the graph can be chosen according to convenience. In the graph given below, the time is considered on the x-axis and the distance is considered on the y-axis. The distance-time graph can be applied on this occasion since the object is moving with uniform speed. Non-uniform speed for the object remains at rest. The definition of moving in uniform speed is that the object is traveling equal distances and equal intervals of time. This statement shows that the distance traveled by the object is directly proportional to the time considered. For in the case of uniform speed, the graph of the distance versus time is a straight line. The graph shows that the distance is increasing at a uniform rate. The distance-time graph can be used to determine the speed of an object. Let us read through the paragraph and understand how this can be done. Let us now read about the velocity time graph. The velocity time graph represents the variation in velocity with the time of an object in a straight line. In this graph, the time is on the x-axis. Let us consider the example of the distance time graph. For a car moving with non-uniform speed, the speed of the car is considered on the y-axis. If a car is moving in uniform velocity, the height of the velocity time graph does not change. It forms a straight line parallel to the x-axis. The displacement of an object moving with uniform velocity is the product of the velocity and the time, which is enclosed by the velocity time graph. An axis, that is the x-axis, will be equal to the magnitude of displacement. Let's see further how to represent different values on the velocity time graph. The time of arrival and departure of a train at three stations A, B and C, and the distance of stations B and C from station A are given. Distance covered from A to B is 120 minus 0 equal to 120 kilometers. Time is 11:15 minus 8:15 equal to 3 hours. Average speed would be 120 by 3 equal to 40 km per hour. Distance covered from B to C is 180 minus 120 equal to 60 kilometers. Time is 13 minus 11:30 equal to 1.5 hours. Average speed is 60 by 1.5 equal to 40 km per hour. Speed is same between A to B and B to C. Time for Firoz and Sanya are given in the form of a table. Distance time graph for the motions on the same scale plotted. The slope represents the speed. Speed of Firoz is faster than Sanya. Therefore, Firoz reaches before Sanya and waits for Sanya. The graph follows non-uniform motion. The motion of an object whose distance time graph is a straight line parallel to the time axis follows uniform motion. The motion of an object, if its speed time graph is a straight line parallel to the time axis, then the graph follows uniform motion. The quantity under the graph gives the distance, magnitude of displacement. Let us go through some of the equations of motion by the graphical method. When an object is moving along a straight line with uniform acceleration, possible to understand its velocity, acceleration during the motion, and the distance it is covered in a certain interval of time. All these physical quantities are set by equations known as the equations of motion. For convenience, three equations are formed, which are as follows. Let us go through some equations for velocity and time relation. Suppose the velocity time graph for an object that is moving under uniform acceleration. We can identify that the initial velocity of the object is u and it later increases to a final velocity v in time t. Change of velocity occurs at a uniform rate. Let us read through the paragraph and try to understand the derivation of this equation. Let us try to understand the equation for position and time relation. Read the following paragraph to understand how the values are derived. Let us now understand the equation for position-velocity relation. Read the following paragraph to understand how the values are derived. Let's understand and discuss the pattern of the numericals given below. Given u is 0, v is 72 km per hour equal to 20 meter per second. Time t is 5 minutes, that is 300 seconds. To find acceleration, a equal to v minus u by t equal to 0 minus 20 by 300 seconds equal to minus 0.06 meter per second square. The distance travelled by the train for attaining this velocity. To as is v square minus u square equal to v square minus 0. 2 equal to v square by 2a equal to 3 kilometers. The acceleration of the train is 1 by 15 meter per second square and the distance travelled is 3 kilometers. Let's understand and discuss the pattern of the numerical given below. Given u is 18 km per hour equal to 5 meter per second. V is 36 km per hour equal to 10 meter per second. Time t is 5 seconds. To find acceleration A is v minus u by t equal to 1 meter per second. Distance travelled by the train for attaining this velocity s equal to ut plus half at square equal to 37.5 meters. The acceleration of the car is 1 meter per second and the distance covered is 37.5 meters. Let's understand and discuss the pattern of the numerical given below. The object can be considered as accelerating when there is a change in its velocity. Change in the velocity can be brought about the change in its magnitude or change in the direction of its motion or both. Consider the example, a body moving along a closed path. Figure A shows the body moving in a rectangular closed track ABCD. Consider an athlete running on this track covering AB, BC, CD and DA. To remain in this track, the athlete is supposed to change the direction of his motion at every turn. Hence, in this rectangle, the athlete will have to change the direction 4 times while running to remain on the track. Now consider figure B, a hexagon. To remain in the track, the athlete runs from AB, BC, CD, DE, EF and AF. To remain in the track, the athlete has to change the direction of the motion 6 times. Similarly, when we consider the example of an octagon in figure D, see the athlete has to change the direction of his motion 8 times to remain on the track. It is observed that as and when the number of the sides of the track increases, the athlete has to take more number of turns. Consider a situation where if the number of sides kept increasing indefinitely. Hence, this leads to the formation of the shape of a circle and the length of each side decreases to a point. Consider the athlete moves with a velocity of constant magnitude along this circular path. The only change in this velocity will be due to the change in the direction of motion. Hence, the motion of an athlete on a circular track can be called as accelerated uniform motion. The accelerated uniform motion can be calculated by the formula where v is the speed, r is the radius of the circular path and t is the time taken. On repetition of this activity a few times and releasing the stone at different positions of the circular path, check whether the direction in which the stone moves remains the same or not. On being released, the stone moves along a straight line tangential to the circular path. The reason for this is that once the stone is released, it continues to move along the direction it has been moving at that instant. This shows that the direction of motion changed at every point when the stone was moving along the circular path. When an athlete throws a hammer or a discus in a sports meet, he holds the hammer or the discus in his hand and gives it a circular motion by rotating his own body. Once released in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released, just like the piece of stone in the activity described above. Important points that we learned in this lesson include: motion can be described in terms of the distance of an object or the full displacement. In other words, motion is a change of position. The motion of an object can be categorized as uniform or non-uniform motion depending on the velocity of the object. That is, if the velocity is constant or changes with fixed intervals of time. The speed of an object is determined by the distance covered for unit time. The velocity of an object is that displacement per unit time. The acceleration of an object is the charge and velocity per unit time. Uniform and non-uniform motions of a set can be explained through graphical figures. The motion of any object that moves at a uniform acceleration can be described by the following formulas. V is u plus at, s is ut plus half at squared, 2as is v squared minus u squared, where u is initial velocity of the object, which moves with uniform acceleration a for time t, v is its final velocity, and s is the distance travelled in time t. If an object is moving in a uniform motion covering a circular path, the motion of this object is called as a uniform circular motion. Answer 1 is as follows. Answer 3 is as follows. Answer 5 is as follows. Let's solve the questions given below. Let's solve the questions given below. So that's it for today. Thank you, class, and I hope you all had fun learning.